called Exploring the N-Dimensional Trade-off Space of Smart Contract Platforms. Just to provide a little bit of context kind of on this one. So last panel we talked about like, store value hypothesis, utility hypothesis, like which one of these things will work, stable coins. This one more specifically is going to be focused on smart contract platforms. The people building these systems have kind of different views on like what kinds of trade-offs they should make. Governance, scalability, latency, decentralization, all kinds of parameters. So the goal of this panel is to really dive into the smart contract platforms and understand like what are the teams thinking in building these systems, why are they making the decisions they're making, and then how does that impact people who are building on top of them. And so we've got a number of folks here who are building some of these systems, and then a number of folks here who are investing in them, and folks building stuff on top of them. So we got one of each. So I guess to get started, guys, please tell us what you do.
My own? Perfect. My name is James Prestwich. I'm the founder and CEO of Integral. We make cross-chain atomic derivatives contracts, so ways to do purchase options between different assets on different chains. So my role here is someone who is building on every smart contract platform that exists and plan to keep building on every new one that people make.
Hey everyone, my name is Ali Yahya, and I'm an investment partner at Andreessen Horrowitz, focusing entirely on crypto.
My name is Zaki Manian. Blockchain scalability has been my weird hobby for 5 years when no one cared. I helped design Cosmos with Jay and Ethan like in the summer of 2016. Definity is basically like me and Dominic's lunch conversations for 4 years. And because they were on the other side of the desk. Right now I work at Tendermint. I'm trying to find new business models for the company. But like in general, I'm not a maximalist of anything, and I just care about like building this awesome infrastructure.
So let's get started off. James, you wrote a post a few months ago called "Miners Are Not Your Friends." Please enlighten us why are miners not our friends?
So the way Bitcoin mining works is you have to constantly be adding hash power because you're paid out relative to the hash power of all the other miners in the system. There's a constant amount of Bitcoin being paid out. You compete for a share of it. So what this means is your business stays profitable if and only if you hash more efficiently than other miners, which means anywhere you can eke out an advantage, you have to do that. So miners in these systems, because they're in a privileged position, they're creating the blocks, they're ordering the transactions, they decide what happens in the block and in what order it happens. So miners eventually will have to manipulate the transactions and their position in the block to take money away from users. In a decentralized exchange, this means front running and taking a vig off of every transaction on the exchange. In other smart contract systems, it might manifest differently. So every platform we make for smart contracts is going to have to deal with this in one way or another, and there aren't any good solutions proposed yet.
Zach, do you disagree? You're building one of these systems?
So the question is, so mining is like, so what excites me about Cosmos in general is we all talk, like everybody like writes all these white papers and has like all of these protocol descriptions. It's all very lovely and beautiful, but like no one's ever actually run a secure system without mining before. We're going to try this summer, and it'll be interesting to see what happens. I think a secure system without mining is a pretty exciting possibility, and we've been trying to build one for 4 years, and it is really hard. The incentives are hard. Like reasoning about incentives, I don't even think we really understand mining incentives yet. Like it may be several more years. In fact, I think the most exciting smart contract that's in Bitcoin is the smart contract that incentivizes miners. That's the most exciting smart contract in all of Bitcoin. Everything else is actually slightly less interesting than that because that's the thing that's like moved the most real capital in the real world is the mining incentive smart contract. And so I'm super excited about building, like trying to build other systems, but like mining at least sort of works, and I'm excited about building another thing that sort of works.
I think one metric that's important when thinking about this question is the degree to which there is overlap between the community of users who actually use the currency or the smart contract platform and the community of miners. And so in the case of Bitcoin, these two communities are mostly non-intersecting, and the miners or regular users of Bitcoin cannot really aspire to be miners. But there are other systems that have been proposed that have better properties that might allow for a greater intersection of these two sets. Like, for example, there's Chia, which is Bram Cohen's project, which uses storage as a resource that is wasted as opposed to cycles of computation by the miners. And because storage is more commoditized, the landscape is flatter. And it's more of a level playing field such that someone with a laptop or with a mobile phone has a better chance of participating as a miner than it would be the case if you're using something like proof of work that's based entirely on just computation and the cost of electricity.
So just one other thing that I think a lot about is there's an incentive alignment between the people who operate the system and the people who use the system today that is a result of the illiquidity of the underlying asset. So if you're a large miner, you end up holding a lot of Bitcoin just because you can't sell that much Bitcoin. And so you become incentivized with long-term Bitcoin holders. Eventually, as these systems mature, this should no longer be the case. And so things will get a lot more adversarial.
I don't think that alignment always holds even today. If you look at BitMaine, for example, the largest manufacturer of mining hardware, BitMaine sells hardware that they know will never ROI. They sell hardware where they know the buyers will take a loss. And that means that BitMaine gets paid up front where their buyers don't get paid at all. And so it kind of breaks the alignment between miners and users when the miners are doomed to never ROI and the hardware manufacturer is taking profits.
Yeah, I mean, BitMaine is extraordinary in the sense that mining is designed to be a perfectly competitive business, so the profit margin should be zero, and BitMaine has sustained long-term profit margins in a perfectly competitive business, which is insane.
Well, it implies that it's not perfectly competitive, doesn't it?
Yeah.
All right, so talk a little about Bitcoin mining. So Zaki, you're building this thing called Tendermint, and that's kind of a core thing in Cosmos. Can you lay out like the vision for us? Like, what's the vision for Cosmos? And let's say things work out in kind of the way you envision them, right? What does that future state of the world look like?
So the future state of, the world that so when I first met Jay Kwan, who invented Tendermint, so he invented Tendermint in 2014. I reviewed the white paper in 2013. I didn't know anything about distributed systems at the time, so I wasn't really qualified to say whether or not it would work, but it seemed like it would work to me. And Jay could break anything else. And Jay used to tell me there's a future in which there are going to be thousands of chains. And I was like, I have no idea what you're talking about, Jay. Why would there be thousands of blockchains? And what's become clear and sort of informed the sort of design of Cosmos was there is a market for secure computation. What we are seeing a lot in the blockchain world is there is a market for computations that are very difficult to fault. And so what we have in Tendermint is sort of a general purpose program that can replicate fault-tolerant computation and check that computation for faults. So this looks like a blockchain. And so what Tendermint basically believes is that there are probably going to be two layers of this system. One layer of the system is the programmable money layer, and the other layer is the dapp layer. And it's sort of a weird design. It's a result of weird path dependence that Ethereum currently thinks of itself as both. And what Cosmos is trying to do is sort of separate the dapp layer from the programmable money layer so that developers can use this Tendermint machine to replicate programs and write really fault-tolerant programs for decentralized exchange or Twitter on a blockchain or whatever the heck that they imagine will be useful for their users. It usually comes into the form of a crypto economic game that drives some sort of utility, and that is separate from the money layer. And then you have Cosmos, which basically moves assets from the money layer into these various applications and out of those various applications. We call it we ended up calling it the Internet of Blockchains. If I could go back in time, I would just call it the sidechain empire. We were trying to build a world of tens of thousands of interoperable sidechains that have very low latency communication between the sidechain and various sources of liquidity.
Can you describe how this vision differs from the broader Ethereum plasma plus sharding vision?
So the main difference is really the question of whether or not there should be a root chain. Is pretty much the difference between sharding. So two things that were very informative in the design of Cosmos is one is we didn't want to depend technically on anything that we didn't know how to build yet. And so sharding, Plasma doesn't, but sharding does require a bunch of primitives that like are research topics at this point, not actual practical engineering yet. And the question of whether or not there was a root chain when we were designing Cosmos, we were like, well, what chain can be a root chain? At that point, when we were designing Cosmos, Ethereum used to go down every day. And so it didn't seem like a dependable thing. In many ways, eventually the Plasma and Cosmos visions kind of merge under some scenarios, and we've been like exploring that with the Ethereum Foundation at this point since like late last year.
So, you know, Ali, like, Cosmos is a world of like thousands of chains, tens of thousands of chains, and like each chain can have its own, basically be sovereign, right? There's all kinds of reasons to be sovereign, government sponsor chains, applications, whatever. You know, Ali, like we're both investors, like what's the case for that happening, like what, right, organically, and then what's the case for that not happening?
Yeah, so I think, given the constraints in terms of performance for existing smart contract platforms, it is a natural thing for, in the short term, for there to be blockchains that are optimized for specific applications that may have the performance requirements that are required by those applications. And so one vision for this is to have an interoperability layer that kind of helps with the security aspect of spinning up a new blockchain and makes it easier for new dapp developers to just spin up, say, like a Cosmos spoke. Is that
Zone.
Zone.
It doesn't really matter.
Yeah, and sort of facilitate the process of getting that up and running and focus on the application development. In the very long run, the question is a little bit more muddled because you may have just existing general smart contract platforms that do end up scaling, and so the case for having an application-specific blockchain is less compelling, since you can simply build an application on top of a more general, unified, and perhaps monolithic smart contract platform. I think one of the things that would clarify the conversation around when it makes sense for there to be something like a sidechain or an application-specific blockchain is to maybe go over what are the many dimensions, what are the end dimensions of smart contract platforms. So, what does the trade-off space look like? And the way that I like to think about it is there are broadly three important categories. There's scalability, there's security, and then there's usability. Decentralization is not one because we think of decentralization more as a means to an end. Scalability, security, and usability are more the things that end users and application developers care about. And for each of those three, there are a couple of sub-axes that are relevant. In the case of scalability, there are three. The three major ones are throughput. How many instructions per second can the smart contract platform support? There's latency to finality. How long do you have to wait before you know what the state of this computational substrate is? And then there's a cost per instruction. In the case of Ethereum, that's the price of gas. How much do you have to pay to run a computation on one of these smart contract platforms? So that's scalability. Then there's security. There are two major things in the realm of security. There's liveness, which is also often referred to as censorship resistance. To what extent will the network continue under adversity? And there's also safety or integrity. To what extent can you trust that it's running the computations correctly? And then there's usability. And usability forks off into usability for developers and usability for end users. And here's where we arrive at things like programmability. From the perspective of developers, like what kinds of programs can I write? From the perspective of developer, you also care about modularity. To what extent can you use other existing building blocks? What building blocks are already included? Things like identity or reputation might be important if you want to build a sophisticated application. And then from the perspective of the end user, you have things like UX and things like privacy, things that you might care about if you're a user of these systems. So depending on all of these things, maybe a smart contract platform that already exists doesn't really offer the right trade-off in this high-dimensional space. And therefore, it makes sense to have a sidechain in Cosmos or in some other interoperability solution that does happen to better suit the requirements of the application. So that may be a framework by which you can reason when this kind of thing makes sense and when it doesn't. And in the short term, it might make sense for a lot of applications. You might end up with thousands, if not more.
James, you're building stuff. What do you want to build on?
Well, I build on all of the chains. So I have kind of a different perspective here. From a developer perspective, the security parameters you mentioned don't matter. Liveness and safety are properties of the chain, and as a developer, I have to just assume that the chain has those. If I don't believe that it has both liveness and safety, I just won't write code for it. So this isn't even a trade-off for a smart contract developer. Well, it doesn't matter. I have to assume, or I'm not doing it at all. I don't care about the safety properties of the chain or the liveness property of the chain. I just have to assume that the chain works. If it doesn't work, I'm not going to use it, and it's not a smart contract platform. So that's not a trade-off. The chain has to have those things. The trade-off for developers is how saturated is the chain? How likely am I to get a transaction in at a reasonable fee rate? What's the block time? How many confirmations do I have to wait for a reasonable degree of surety that my transaction is in there? And also, what kinds of programs can I write? Like you mentioned, developer usability. But that's not about what language are things written in. It's how hard it is for my transactions to interfere with each other. When I'm a developer writing code that's supposed to run on a blockchain, I'm moving tens of thousands of dollars around. I don't want a super expressive, stateful language and system where everything will step on, where all of my transactions will step on each other's toes. I want something that's stupid simple so that I can write code and know exactly how it will run. The problem isn't the expressiveness, it's the statefulness. With the parity bugs last year, the problem wasn't that you could do a lot with the language. The problem was the developers did not understand the state of the system that they wrote.
Sure, yeah, I mean, I think I would disagree with respect to the comment about security. So I think those two things are not binary, and that the liveness and integrity guarantees are not just on or off. There is a spectrum there's a continuum along which you can move. Mm-hmm. And one way to reason about this is just the cost of attacking a particular system and subverting either its liveness or its safety. And some systems, for some systems, the cost of that is much higher than for others. Mm-hmm. And you can talk about for your application, what do you actually care about? Do you care about nation-state grade security? Do you care about getting attacked by China or by some other very powerful nation-state? Or do you care about platform grade security? Is the set of attackers smaller and less well-funded? And based on that, you can reason about what properties the chain should have. And there is a trade-off, because if you do want nation-state grade security, you have to give in other dimensions. With respect to the comment about programmability, I completely agree with you. I think programmability is another continuum. You can have a full Turing complete programming language that's supported by the smart contract platform, and that may be very good for some applications. It may be required for some applications, but that also has its drawbacks. As you mentioned, the parity bug. It's something that would have been hard for the developers to foresee, because reasoning about Turing complete code is difficult. And so for some applications that maybe are more mission and life critical, you might want a more restricted programming language that maybe supports things like formal verification, so that you can reason about the correctness of the program more easily. But then you lose on the expressibility. And there are some applications, some programs that you can't write in those programming languages. So I do think it's a trade-off. I do think these are things that developers think about and care about, and they will pick the systems that have the right set of properties.
So this is a little technical. Let's try and just zoom out a couple levels. So one of the major things in the kind of debates in these systems is governance, right? You can't have tightly coupled on-chain governance and informal off-chain governance. Those two things are mutually exclusive. Different people think about these things in different ways. I guess if you guys could sort of, as you think about, Zaki, let's talk about Cosmos, how you guys think about that there, and then we can kind of dive into that. Governance, I think, is understandable. And just for a little bit of context for the word governance, This really refers to, I guess, a few categories of things. One is like, how do you upgrade the chain? Right? Like these things aren't static, they need to evolve technically. And kind of the other probably major category of this is how do you deal with reverting transactions, if at all? So like if there's a bug in the system and money blows up, if there's theft, and then arbitrating disputes. So those are kind of the two major categories of governance. There may be some others, but within that context, I guess, Zach, if you could start off, like how do you guys think about this for Cosmos?
Yeah, so we've definitely started thinking about this early. And so probably the first thing to understand about Cosmos is that that informs every other decision and why we had to build our own token is like, I don't know, when we made the decision to have our own token, it was not as common as it is today, and the regulatory uncertainty was very high, and we had to feel like that this experiment was really the only way to do it. And we realized that in order to run the experiment that we thought was interesting and important, we needed a system that supported multiple tokens. And so the atom on Cosmos is security and governance of the system, and it has no other function, and it should be valuable based on discounted cash flow from operating the system into the future. And so the fact that we have an atom allows us to do inflationary and slashing sort of carrots and sticks in that token that incentivize behavior that we think will be good for the network. And so we incentivize both at the security layer and incentivize at the governance layer. So we want the people who are operating the network, who hold atoms and are responsible for the future of the network, to participate in governance. And if they don't participate, if you actually don't vote, it's one of the slashing conditions. So we're expecting to create this environment in which, and there are certain things that also, if you don't assume future cryptographic research, we can't solve with anything other than human intervention. So if a blockchain that's connected to Cosmos loses its safety property, which we discussed, so essentially it forks, there isn't any sort of generic way to deal with that situation. So the flexibility of Cosmos is that we could connect to any blockchain, but that blockchain may fail, it may fork. And we don't really see a lot of failures today of blockchains, but most of us who are building these systems anticipate blockchains will fail under attack in the future. And so the biggest and most important responsibilities of governance are A, to decide how the software is upgraded, what is the thing that we should move from running today to tomorrow, and then how do we deal with failure? It's possible to imagine systems that give us the ability to deal with more kinds of failure in a completely automated in-protocol way, but we didn't assume that in the design of Cosmos. So that's why we needed governance.
Ali, you look at a lot of these things, right? Like, do you care about governance when you look to invest? What scares you? What excites you?
Yeah, so I think the way that, and I won't speak for the entire firm, but my sense is that on-chain governance is important in the long run, but a bit of a distraction in the short term. I think, actually, I don't know if you, Kyle, have written about this, but we might have similar views about this. Like the more important problems that need to be tackled in the space are the problems of scalability, the problems of privacy. There's a large set of problems that are critical and existential in order for real applications to be built on top of smart contract platforms, and in order for us to achieve the scale and adoption that we aspire to. Those problems should take precedence over on-chain governance as a way of sort of more seamlessly improving or evolving the protocol. One way of justifying this is to say that off-chain governance, the traditional human level of governance, is enough. And that you want to some extent a benevolent dictator to lead the community and to influence most of the decisions that are made with respect to the evolution of the protocol, especially early on when there's a lot of uncertainty. You do not want all decisions to be made by committee. You do not want to put things up to a vote to all stakeholders, especially because it's likely that most stakeholders probably don't know what's best for the long term of the system. And the leader has to be able to make unpopular decisions that they may know are what's in the best interest of the community and of the platform. And in the case, like the counter argument to that is you don't want totalitarian control. You don't want a dictator that ceases to be benevolent. But the nice thing about the space is that there is this recourse. There is a system of checks and balances, and that is open source. If Vitalik were to become a tyrant, it is still possible for the community to fork the protocol and to go their own way, and this has happened in the past. And so it is expensive to fork, but it's a good thing that it's expensive because Vitalik should be able to make decisions that are unpopular. And so that's generally our view with respect to governance. We're less excited about protocols that are jumping too quickly into introducing some protocol layer way of voting for what improvements should be made versus what improvements should be discarded.
I definitely agree with that approach. The one thing that we should learn from human history is that humans are really bad at designing governance systems. Really, really, really bad at it. And anything that you write in code as a governance system will not change. You will be stuck with it for the next however long your chain lasts, and it will be wrong. So that's why we try to stick to off-chain human governance over these things.
For what it's worth, I totally concur on the record saying, let the smart guys building these things figure it out. All right, we have just a few more minutes for this session. One of the favorite debates is scalability versus decentralization. You can't really build usable applications, at least consumer-facing usable applications on Ethereum today. Cosmos aims to solve this. A lot of other people are taking different approaches. What are your concerns? Ali, you're investing in a bunch of these things, right? What concerns do you have and what excites you?
Yeah, I think the main concern is, for any one particular investment, the concern is that the community of developers who want to build applications on top of the smart contract platform in question may decide to move to elsewhere just because the performance requirements are not met. And one big risk here is the possibility that there's widespread disillusionment about the idea of decentralization, and that we regress back to a model that doesn't really live up to the promise of having a platform that truly is neutral and fair and isn't controlled by a small group or a single central entity. So you can imagine a world where the chimera of some veneer of decentralization that actually is centralized ends up stealing the hearts and minds of developers, and that the true vision of having a real platform that is neutral and that is fair gets lost or gets delayed by a very long period of time. And I feel like I'm in a different point in terms of view with regards to which platforms may fall into the category of not really being decentralized, even though they claim that they do, within the team and maybe within, generally within the team at the firm. And so I'm more on the side of optimizing for true decentralization. And my concern is that the technology that's needed in order for that to happen may not come quickly enough.
Is it really such a bad thing if devs leave the ecosystem because of scalability issues? My laptop in my backpack back there has the full genome of every CryptoKitty ever, despite how much I don't care about CryptoKitties. A blockchain is a commons, and it suffers from the tragedy of the commons. If there aren't real costs to using it, we're going to end up with permanent immutable records of digital cats clogging up everything forever. That's where we're at now, and we need to figure out how to fix that situation so that this is an actual usable piece of infrastructure instead of a toy.
I'm less concerned right now that the technology won't arrive. I have yet to really see anyone who's building anything that wasn't in the design space of what people what we used to talk about in 2014 when no one cared. I haven't really seen anyone building anything like that. It was just we didn't have the resources to actually build secure systems at scale. And so basically the centralization concern is mostly that we will end up building something that's insecure. And isn't as secure as advertised. And hopefully we don't have to do that, because I certainly know how to build something scalable that is as secure as we'd like it to be.
Yeah, on this topic of trade-offs, the trade-off of sharding is decreased security for every shard.
Yeah, but you can mitigate a lot of that in a lot of ways.
Mitigate.
Yeah. So it's just a question of like, but like the thing that I think is going to be the hardest challenge of the next, like a year or two out from now, is just the compositionality of all these things. Like how do different platforms compose together? You know, when I talk to people who make Ethereum ERC20 wallets about like what wallets will need to look like in the world of Plasma and Cosmos and sharding, they're like, their brains break a little bit, and then they're like, okay, well, and then I'm like, we're gonna have to invent a bunch of new things so you can actually deliver a usable experience, so that like an asset can move across systems from one system with one set of trade-offs to another system with other sets of trade-offs, and users have some sort of control and understanding of what's actually happening.
Well, and when we're talking about Cosmos or sharding or Plasma or other systems with potentially thousands of chains, what we need as developers for that is push-button deployment of everything that has ever been written today in terms of tooling. We need to get to the point where we can deploy the entire 2018 blockchain tooling system in an afternoon, and that any developer anywhere can do that.
Yeah.
And we are so far from that. Even if we solve scaling this year, it will still be 10 years before we can take advantage of it.
Okay, not 10 years. Do it next year.
Hopefully some of our investments will take advantage of it sooner. All right, so done with kind of the core panel. This was a little bit abstract. That was kind of the intention, like more kind of abstract, like the hard things that we're thinking about as builders and professional investors in the space. Everyone here on stage is intimately familiar with all the major platforms: Ethereum, EOS, Definity, Tezos, etc., or at least moderately, if not intimately familiar. So with that, we can open up with questions and kind of dive into anything smart contract related. We got a first question right here and then over there.
So James mentioned liveness and safety as reasons why he wouldn't necessarily build on a smart contract platform. So I wanted to ask you guys, from a developer's perspective, are there other disqualifying factors that will result in you guys not wanting to develop on top of that platform?
If it's not live and it's not safe, I'm not going to use it. Like, these have to be unquestionable features, otherwise you're betraying your users. I'm not sure there are any other disqualifying features. Liveness and safety are necessary properties of a blockchain or a smart contract system.
There may be certain applications that absolutely require a form of privacy. So there are entrepreneurs who are very much, they're building things that depend on the existence of privacy solutions for some of the existing smart contract platforms.
Yeah, I think a lot about, and to a certain extent, I feel a little, like most of my focus over the last year has been scalability, not privacy. I don't think that these systems will be useful until we have both. I roughly know how to do it from a technical architecture point of view. It seemed like the more important problem to solve this year was scalability, and maybe the problem of the next 2 years is developer tooling and privacy.
So thanks for being here today, by the way. Great panel. I noticed that decentralization came up a lot in this, as it always does. And I'm curious for each of you, what is the definition of decentralization? Is it more about a decentralized developer base or decentralized people doing work on the system? What's most important in your view?
So I view decentralization as simply one way of achieving security. And so I don't really think about very much how decentralized my platform is. I think about how much it costs to attack my platform. And that's what I spend all day thinking about. And what Bitcoin is trying, what people who want decentralization are trying to achieve is they're trying to say that uninvalid state transition, so you can think of the DAO hard fork as an invalid state transition, is under the pre-existing protocol rules, that was an invalid change, moving money from an account to another account without a signature of the account owner. That's the classic invalid state transition attack. And what we care about is how expensive that attack is. In a system where that attack is cheap, you would not want to have many billions of dollars riding on top of that system, because that means an attacker can transfer those billions of dollars from their account to from your account to their account. That's what we care about.
I would completely agree with Zaki that decentralization is not an end in itself, and it's more a means to an end. But that being said, I think there are three different vectors to think about when talking about decentralization. There's decentralization of consensus, is who in the network gets to decide what the next block is. There's decentralization of control over the protocol evolution, so who are the developers who get to merge pull requests into the code base. And then there's decentralization of wealth, like who controls the vast majority of the assets in any one particular smart contract economy. And those three things influence the things that you actually care about, which, as I had described earlier, are scalability, security, and usability.
For me, it's about my ability to participate in the system. Decentralization is about my control over my hardware and software and what it does. So when we're talking about a lot of these scalable systems, we're taking it from a system where I can, at home, run a node that fully participates in the system and validates all state changes to a system where I no longer can do that and must rely on other people to do that for me. So for me, what matters is my ability to run a Bitcoin node or an Ethereum node and to continue doing that, because that is how I have control over my participation in this system.
I think there's a question there. Miles, if you can get him a mic. Oh, you've got one.
Yeah, I have a question for you guys. So we talked about some of the dimensions here, the end dimensions and the trade-offs. Why can't I have it all? Is it like just completely impossible? Is this like some law of physics level, like fundamental law that I can't have it all?
Yes.
Or is this just like we haven't figured it out yet and someone will
I
figure it out?
disagree. I think you can have it all.
There
think
is
it's gonna
a
take
mathematical proof that you can't have it all.
Can you walk us
It's
through?
called the FLP impossibility result. It says that you can't have an asynchronous consensus system. So
This is why we invited James.
all of these systems we're talking about here, all of them are doing end runs around this impossibility result to get something that's just close to good enough. Bitcoin says we'll never reach consensus, so we can be asynchronous. Cosmos, another proof of stake, says we'll be synchronous, so we can reach consensus. But the trade-off there is that if you go offline in Cosmos, you no longer have these security guarantees that you used to. So we're all trying to just build different things in this trade-off space. There's no way to have it all.
Yeah, there's also another theorem called the cap theorem, which says that if you want partition tolerance, which is something that you absolutely need in order to build a network that's global, and by partition tolerance we mean that we need to be robust to the network partitioning and not being able to communicate across the partition. So if we want that property, we want the network to continue to exist even if that happens, then there's a trade-off between consistency, as in like both partitions have the same state, and therefore the state is consistent, and on the other hand, availability, that people in the network can still interact with the network and the network is still live. And it's easy to see why this is the case, right? If you have a partition in a network and you want consistency, then you have to stop until the partition resolves itself in order to continue. Otherwise, the two partitions will diverge and will become inconsistent. But if you want availability, then the two partitions will diverge, so you will no longer have consistency. So you have to pick one of these two. And there are trade-offs associated with picking one or the other. So the Bitcoin picks availability. If you have a partition, or if you have a partition, you end up with just two forks of the Bitcoin chain. And therefore, Bitcoin, the trade-off that it makes is that you have probabilistic finality, and it takes longer for you to be confident that the state of the Bitcoin chain is the correct state. And there are other systems that opt for consistency instead of availability, but then there's a concern that liveness may get compromised if there is a large enough partition in the network.
So the reason I say you can have both is Plasma is a really good example of how you compose two different kinds of systems and sort of optimize the trade-offs between them. The core insight of Plasma is that if you have one system that is probabilistic consensus and never truly reaches consensus, and you run a synchronous system on top of it that reaches consensus, that needs synchrony to achieve liveness, and then you combine the two things, you can actually get some of the advantages of the synchronous system without giving up all of the security properties of the asynchronous system. So these sorts of things, these compositions of things are really hard right now because we don't have the basic building blocks. Like, other than Tendermint, nobody else in the world makes an actual BFT consensus engine. Like, we're the only people in the world who have a production BFT consensus engine. And it is a really hard thing to build. So until we have all of the building blocks of zero-knowledge proofs, fraud proofs, BFT consensus engines, all of these things, we can't start composing them together, but it's from the composition of all of them that we get the best of all worlds.
But even then, you're talking about allowing people to choose trade-offs. That's the point of Cosmos zones, is that people get to choose
But
different
like the
trade-offs.
plasma exit procedure gives you the ability to redeem your funds if your zone is no longer live.
Assuming some amount of synchrony.
And there's still a trade-off, right? There's a trade-off of latency, and there's a trade-off of the security of the subchain being smaller than the security of the overall system. And you're trading security in the time dimension, in that if you don't settle back with the main chain often enough, then the
Yeah,
security
it's-
guarantees are less.
It's super complicated.
And
It is about all these things.
to be clear,
And
like,
no one will, like, ultimately, but I think in a few years we can build a system that has like relatively good properties
Yeah.
across, and that like you don't think about what your CPU is doing and like all of the trade-offs that CPU designers made to make your CPU do what it did until those trade-offs break, like Meltdown and Spectre. Like we'll be able to have a system in a few years that most people who use these systems don't have to think about all of these subtle trade-offs. It's all just abstracted over.
and to be clear, I don't think that this is a bad outcome. I was talking about participation earlier. Part of the participation is being able to choose my trade-offs. We've never been able to make the choice of financial sovereignty before. We've never been able to make the choice to use smart contracts before. We've unlocked, a new possibility for how we can interact with each other, and we're talking about trade-offs up here, debating like which is better, but it's about being able to make the choice, being able to participate, which nobody has ever been able to participate before.
So if you're wondering what we do at Multicoin, like this is the kind of stuff that we spend our time discussing. Awesome. With that, we're out of time, guys. Zaki, Ali, James, thank you all.